All right, welcome to the second video of this series for the CMPE 1250 Embedded Systems Fundamentals course. So in the last video, we went over the documents for the Nucleo G031K8 development board that we're going to be using for this course, as well as the datasheet and reference manual for the microcontroller. We did talk about debugging a few things. So I should probably mention that I added here to this list on the development board section an actual development board schematics, which is called Nucleo G031K8 schematics. You can download that one directly from here. I already have it open with Adobe. And it shows here, this is from ST, Microelectronics. It shows some hierarchical hardware development here, showing these two sections. Actually, when you open this on the PCB software, PCB design software, you can click on this and it opens a different sheet. But in this case, it's sold as a PDF, so I guess that doesn't work. But basically, at a very high level on these schematics, we have a power section, because any board that we develop that has a microcontroller needs to have a power section, a power supply. So this is actually, as I briefly mentioned, power from the USB. There's also a mechanical view that shows like dimensions here of the PCB design. And there are two sections here. One is the debugging, the ST-Link, and the other one is the microcontroller. So when we look at this, and they both communicate, we have to understand that we're looking at the right sheet, right? So we're not really going to be dealing with the debugging microcontroller with ST-Link. We're going to leave that aside. That's all handled behind the scenes for us. We're going to be using these microcontroller to be programmed and for the applications of this course. So that refers to this guy, the STM32G031K8, okay? And these are the pins and ports. We'll talk about what a port is later and where they are connected, each one of these pins to this actual couple of headers that we have on the Nucleo board. And all the other components, the button, the reset button, the crystal, the 32 kilohertz crystal, the decoupling capacitors here, the power supply, and all that. So if we scroll to the next sheet, this refers to the debugging microcontroller. See, so we're not really going to be dealing with this guy. This guy has its own firmware or program running, and it's solely used for interfacing the actual microcontroller with the computer and the IDE, as I explained before. So we're mainly going to be focusing on this guy. So the schematics are here in case you want to take a look. Okay, so that is for the actual development board and microcontroller hardware and documents. Now I have divided here in two other sections the tools, and I have labeled them as Seger tools and ST tools. And the reason why I've done that, maybe I should put ST tools first, because our microcontroller is manufactured by ST Microelectronics. Okay, so if we click in here, we have two pieces of software that we need from ST to download and install, as well as the tools from Seger. And why are we using Seger? Because Seger is actually the provider of the IDE that we're going to use for this microcontroller. IDE stands for Integrated Development Environment. So there are many different IDEs that can be used with this microcontroller. ST has its own IDE, which is the Cube IDE, and we chose not to use that one because we believe that Seger IDE, Seger Embedded Studio is actually better, which is why we'll be using that. Okay, so we're going to have a mix of tools from ST Microelectronics and Seger, and I will go over those in detail soon. Now, Also, I should probably mention in these two last links here, I have the links to the actual Nucleo development board and the microcontroller documentation site. And I hate when Brightspace does that, but so these two links are actually links to the actual site on ST Microelectronics, and all the documentation that I provided earlier is in here. It's just that it's way more. That is why we have tried to summarize everything in here. But in case you want to, research further or look for more information, you can find all the resources in these two links. But with what we provided you with here should be good enough for the purpose of this course and even the following one. Okay. Now, another section that I added here is an ARM Cortex-M documentation section, because what we need to understand is that this microcontroller that we're using for this course is actually an ARM microcontroller. Okay, let me just connect this thing here, see if I can actually have some notes here. I should probably open the whiteboard. So the manufacturer of this microcontroller, of the core, is ARM. Okay. Now we have different vendors, so different manufacturers that will use an ARM core. Okay. So we have, for example, Texas Instruments. We have ST, which is our case. We also have NXP. All those are different companies that could develop something with an ARM core. Okay. So why am I explaining this? Well, because I added this link here to the documentation from ARM. So if you want to look at the actual documentation for the core and understand what kind of microcontroller are we using. So if we look at the products that are from ARM here, we have Cortex-X, ARM. So our particular micro lives in this family, Cortex-M. And as you can see, the Cortex-M are different micros, and they all depend on the type of application that we're using. If it's more complex, it requires more power, more functions. And very down here, we see as the simplest one, which is why we chose this one, the Cortex-M0 Plus and the Cortex-M0. So the Cortex-M0 Plus is the one that we are using, and is an improved version of the Cortex-M0. So it's just highly optimized for low power modes and to preserve energy. So basically it's a low power M0. That's what it is. Okay. And this is the kind of microcontroller that we're using. And if you want to look at the specifications and everything, it's all in here. Okay. And like I said, there could be different vendors. It could be Texas Instruments, ST, NXP. So why we chose STM32, we chose a micro from ST, from a development board from ST, is because they actually provide good documentation, and the development boards are a good price, cheap price, and everything works well for us. That's why we chose that one. Okay. But we have to understand that ultimately the microcontroller has an ARM Cortex-M0 Plus core, and that makes more sense when we look at this common microcontroller software interface standard. Of course, I don't expect you to understand any of this. I'm just showing you that this is all the documentation related to the Cortex-M microcontrollers. And seeing the core here, you can see the different families of Cortex-M and all that. And the idea of this, the common microcontroller software interface standard, is that since all these different versions of this core M0 Plus are basically the same, ultimately, if you follow this standard, it doesn't matter which vendor you use. If you use a micro from TI, from NXP or from ST Microelectronics. So everything should remain the same if you follow this standard. Okay, if you use what we call bare metal programming. Okay, and also we did talk about the debugging, and the debugging interface that we saw in this development board here is referred to as ST-Link. I think I cannot really scroll on this page here. Give me just a second. Yeah, so if we go to this, we see here that the debugging interface is an ST-Link. Okay. Now, if we look at the Seger tools, they have something similar called J-Link. So J-Link and ST-Link are kind of similar. And ultimately what they are just means of implementing this common standard, which is the ARM SWD standard. And that is actually explained here. So remember the debugging interface. Let me see if I can explain this here. So we have our computer here, right? Let's say this is our computer. And then we have our microcontroller unit here. And we need some sort of interface. And that is the debugging, okay? So because we're going to use a text editor to write our code, to compile it, and to ultimately build a binary that needs to go and run in this guy, okay? But that doesn't happen directly, so you need an interface, which is a debugging interface, to be able to communicate with this other microcontroller and send the binary. So in some other cases, you will use a specific box that would have inside a debugging interface to program the actual target microcontroller. In this case, in this development board, everything is integrated. And that's why I showed you that we had a micro on the top and on the bottom side of the board. So everything is integrated on the same board. So this debugging capability, we have it already on board. And all we need is just a USB cable to connect to the actual computer. Okay? So, and these debugging interfaces, there are many different standards, and one typical one that is known is the JTAG, but ARM has its own version of it, which is a simplified version that uses less pins, and that is what is called SWD, as in serial wire debug. Okay, so SWD is serial wire debug, and ultimately uses two pins, SW clock and SWS, I believe it is a pin. Yeah, so the serial wire and the clock plus a reset pin. So actually uses 3 pins, as opposed to the JTAG that uses many more pins. So when it comes to, let's go back to here. So we said that SWD is a serial wire debug interface from ARM because our core, the core of our microcontroller, is a Cortex M0 Plus, which is from ARM. But in particular, we're using an ST version of it by ST Microelectronics. So ST provides you with this ST-Link debugging, and Seger will provide you with J-Link debugging, but ultimately both of them are kind of built on top of the same thing. So SWD could actually be implemented by ST-Link or J-Link. And there are more, right? There's Open, I can't remember the name right now. I think it's Open C MC Sys, something like that. There are some other implementations. So we're not using this two. We're going to use one of the two, but it's what I'm saying is that the ST-Link is from ST Microelectronics and J-Link is from Seger, which is the vendor for our IDE that we're going to be using. Okay, so what I'm going to do now is to connect the microcontroller. So let me just bring up the camera. And it's going to become very bright, so probably it's not going to look that well, but it's just to show you that the thing comes on. So I'm going to turn on the port and the board comes on. And when that happens, I can see here in my device manager that two things will show up. One is the ST-Link debug USB interface, which is a debugging interface, as well as a virtual COM port, which is like a serial port, also says ST Microelectronics. Okay, so from what I've said and from what I've seen here, we could conclude that this board actually is set up to work with ST-Link because it's showing ST-Link and it's showing ST-Link virtual COM. Okay, however, if we wanted to make this board to work as a J-Link, we have a link here to this ST-Link reflash utility from Seger, which can actually allows us, I already downloaded that, it can allows us to convert these interface from ST-Link to J-Link. Okay, and that is right here. And it's just a portable version that we execute and can run. So when we do this, we have to accept, and it tells us that we need to accept again, I think, that we have an ST-Link compatible microcontroller. And if we want to upgrade it and convert it into a J-Link, we can select number 1 and we can do so. Now, if we read this license here, what this is telling us is that we are only allowed to do this on a development board. So since we are working with a development board, this one here from ST-Link, we can do that. But if we were to design our own custom board, we cannot really do this. Okay, but it's 100% legal that we do this with a development board. Okay, so what we're going to be doing here, we're going to convert this to J-Link, and that's going to update the firmware of the debugger. See, it recognized that it had an ST-Link. And if I go back to my device manager, what's interesting here is that I no longer have an ST-Link debug, but I have a J-Link somewhere in here. See? And in my COM port, I also have a J-Link virtual COM as opposed to an ST-Link. So if I wanted to reverse the process and go back to the original ST-Link, I could restore ST-Link with the option 3 here with this tool, and I could leave it as default. So the reason why I want to explore this option is because if we use J-Link, everything is going to be easier and more compatible with Seger Embedded Studio, which is the IDE that we're going to be using for this micro, right? So if we want to use this IDE with ST-Link, of course we can do so, but it requires more steps, okay? So which is why I think for the purpose of this course and the following one, and since we're using a development board, we could just convert our ST-Link to J-Link and everything will be easier to configure when it comes to the IDE. So what tools do we have to install to follow this process then? So what we need to do is download this reflash utility and do this process and make sure that in our device manager, our ST-Link gets converted to a J-Link. So in the following video, what we're going to be doing is to install the rest of the software to be able to communicate with this board. We need to install the J-Link software, the Seger Embedded Studio, which is the IDE, and we also need to install the tools from ST, which is the CubeMX and the Cube Programmer. Now the Cube Programmer will only be necessary if we're using ST-Link, but we will install it anyway, just to have it there, just in case. But CubeMX, I will explain later what it's for, and it's very useful and necessary for our development process. So that is it for this video.